Let's say that I have a penny with water on top of it and it looks like this. Now the reason that this penny can hold so many water drops on top of it is due to surface tension. Now I'm pretty sure you've heard of surface tension before, but in the context of water, surface tension is caused when cohesion and adhesion both happen at the same time. Now in order to understand what surface tension is and how it relates to water, you first must understand the difference between cohesion and adhesion. Cohesion is when water sticks to water, or in other terms, when water sticks to itself. Looking at water at a smaller level, we can see that it consists of 2 hydrogen atoms and 1 oxygen atom per water molecule, and that is where we get the formula H2O from 2 hydrogens and 1 oxygen. So the oxygen atom is attracted to the hydrogen atoms, and the hydrogen atom stays there due to oxygen having a negative charge and hydrogen having a positive one. The bond that holds this together is known as a covalent bond. Now the reason why oxygen has a negative charge is because it is more electronegative than hydrogen due to its size, and that's why it's bigger in diagrams and drawings. And because of its size, it has a tendency to pull more electrons towards it. Now since the positive charge of hydrogen is attracted to the negative charge of oxygen in a singular water molecule, this statement also holds true when multiple water molecules interact with each other. To reiterate, the bonds that hold a single water molecule together are known as a covalent bond. This bond is what's called a hydrogen bond, and as you can see, it is the bond formed between 2 separate water molecules. Now to tie this concept in on a larger scale, we'll use a real-world example because I find that they help me remember the information better. So keeping in mind what we just discussed regarding water molecules, covalent bonds, and hydrogen bonds, this glass of water has thousands of tiny individual water molecules that essentially hold other water molecules up by hydrogen bonds. And to sum up the topic of cohesion in water, it is when water sticks to itself through the process of covalent bonds and hydrogen bonds due to oxygen and hydrogen's opposite charges. Now that we've covered cohesion, we can apply what we've just learned to understand adhesion. Adhesion is when one substance, which in this case is water, is attracted to another substance with different properties than it. The most common example that you'll probably see is water in a test tube forming a meniscus. I know that I'm throwing all of these new terms at you, but you'll see that they will all connect to each other to make logical sense later. Back to the meniscus. There are 2 types of meniscuses, which are a concave meniscus and a convex meniscus. Whether a meniscus is convex or concave is determined by its water properties, which is what we've been talking about throughout the entire video. A concave meniscus is formed when the force of water adhesion is greater to the tube than the cohesion of water to itself. And in other words, the water is more attracted to the sides of the test tube than it is to itself, forming a concave meniscus. A convex meniscus is formed when the force of water cohesion is greater to itself than the force of adhesion to the sides of the test tube. So in other words, it is when the water is more attracted to itself than it is to the sides of the test tube, creating a convex meniscus. Now, how do all of the concepts and terms that I've just explained relate back to surface tension of water on a penny? Simple, really. The water is held together by cohesive forces and hydrogen bonds, and this creates tension, which pulls the water molecules towards itself and supports its weight. The bottom surface of the water drop then sticks to the penny due to adhesion between the water and the surface of the penny. And that's cohesion, adhesion, and how it relates to surface tension. I hope that you learned something from this video, and if you did, feel free to subscribe and drop a like.